All right, everybody. I realise people are still filtering in, but we'll get the kind of preamble started while everyone's doing that, because I have 72 slides and code demos to get through, so it's quite a challenge in an hour. So I don't want to waste too much time while we kind of wait around for everyone to appear. So hopefully you are here to see me talk about clean architecture, which is Bob Martin's principle that there have been a number of architectures and design approaches over time that are essentially the same thing, and he's kind of taken the best of those principles and synthesized it together. My name is Ian Cooper. There's my Twitter handle there on the bottom of the screen, and my GitHub address. The slides and the code are all on GitHub if you want to obtain them. You can even get them during the presentation if you would like. So who am I? I'm just old. Most of that is unimportant. So we will move on quickly. I work on an open source project called Brighter. Brighter and a sister project called Darker can essentially be used to help you build CQRS systems, and you'll see a tiny bit of code from them at the end. So Brighter can be used and Darker can be used a similar way to Mediator. But they also support out-of-process handlers, similar to, say, mass transit and then service bus. So you may want to check those out. I haven't got any stickers. We went for ages trying to get Scott Hanselman to tweet about us or write a blog post about us so that we get some visibility. We couldn't get anything, and then we got stickers printed. And Scott was kind of like, "Oh, I'm going to talk about them now that we've got stickers." So that's the key if you have an open source project: get stickers. Okay, what's our agenda? So I'm going to start by talking about this idea of coupling and cohesion. Hopefully for many of you that's a bit of a refresher. And then we'll talk from that about what layering is. I know that the cool kids are down on layering. They're wrong, and I will explain to you why they're wrong to be down on layering. We'll talk a little bit about domain models, where kind of behavior and state goes in relation particularly to layering. And then we'll talk about this old idea called the use case controller, specifically. There's also another idea we'll talk about. When people talk about vertical slice architectures, they are really just repeating stuff from 20 years ago called use case controllers or boundary controller entity. And then we'll talk about the clean architecture itself, which really builds on everything we talked about earlier, and we'll show you exactly what Uncle Bob is proposing the synthesized version of this architecture looks like. And then we will do a quick demo in .NET of taking code from maybe in a format you have it in today, where a lot of your behavior is inside your web controller, and pushing it through to this architecture by a series of steps. Okay, so quite ambitious. Okay. This is Robert Martin and his book, Clean Architecture. Robert Martin, obviously, for those that don't know him, is mainly famous for a book called Agile Software Engineering, where he introduced the solid principles and a series of principles basically around components as well, which don't get as referenced, which are relevant to this talk. But this book, Clean Architecture, identified that a number of people, so we'll pick out three of them, have come up with the same architecture. So Alistair Cockburn created this idea called ports and adapters. Who's heard of the ports and adapters architecture? Anyone? Okay, a few of you. Jeffrey Palermo independently came up with an idea called the onion architecture. Who's heard of the onion architecture? Okay, more of you. So yeah, at the time that happened, a lot of us were saying, "Hey, Jeffrey, don't you know about ports and adapters?" But the evidence does seem to be it's been created independently a number of times. And Ivor Jacobson, everyone know who Ivor Jacobson is? Do the youngsters amongst you know who Ivor Jacobson is? Hands? No. So Ivor Jacobson is one of the godfathers of object orientation, and he's the guy behind particularly use cases, the rational unified process, and he came up with an idea called boundaries, controllers, and entities. Okay. So we'll kind of start at the beginning and work our way up to where Bob is. So one of my current job titles includes the word architect, and while we can be down on that title or not, one of the key things that's an activity of architecture is partitioning your system. In other words, slicing your system up into pieces to make it usually more maintainable. Right? Software spends most of its cost in maintenance. So really when we talk about improving, for example, the productivity of development teams, it's a false goal to say that our real objective for improving productivity is to see teams deliver to market quicker for this given one project. What we want to see is to have software that's easily maintainable so they can continue to deliver to market in a productive fashion. What we can get if we don't address this issue is that you get your startup, you release quickly, you get out into market, you start building your software, and then at some point you realize the cost of shipping any new feature change is huge. People in the business start saying to you, why is it so expensive to get software out the door? And the answer usually is that you have high coupling and poor cohesion. So we want to basically reduce the coupling and improve the cohesion to improve the modifiability of the system. And what we can really identify the clean architecture as is a system that's prioritizing maintenance. And it's prioritizing having low coupling and high cohesion in the system. So it's saying, I want to build an architecture that will make it easy to change this software in the future. And if we're doing agile software development and we want to say we don't want too much upfront architecture, what we want to do is have an evolutionary design. We need to have an architecture that supports evolutionary design. We don't just get it for free. And so things like the clean architecture are ideal for supporting agile approaches, and they're ideal for supporting things like test-driven development. Okay. So a bit of a refresher. Coupling is the property that a module is forced to change because another does, right? So I have module A and I have module B, and module A depends on some code in module B. And if I change module B, there's a risk that I also have to change module A. Either because the API surface area to module B, the things that are public and exposed from it change, so I have to go away and change the code in module A because I've changed the name of a method or the number of parameters it takes. Or more subtly, the behavior in module B changes. Okay, so the way that essentially I write state or some side effects change, and module A has to take account sometimes of the fact that we've changed in some way in that area. We can get into real problems if we have duplication between module A and module B. And that is, for example, I worked in a finance system that calculated deltas and gammas, etc., for given portfolios that you had. And that was written back in the day when we had everything was a rich client written in Windows Forms or WPF sitting on someone's machine. And we had two places, for example, actually I think there's more than two, where some of these values were calculated. And that meant if we decided that this calculation was off, the problem was if you went and changed one, this would now be out of sync with the others, and customers would phone up and say, why is my delta this value on this page and this value on this page? We had coupling of knowledge because you had to change that piece of knowledge everywhere without the system. So we can say that we're loosely coupled. If we change to one, the details of one module doesn't impact another module. And duplicated code is a common smell of coupling. Okay. So cohesion. So cohesion is the property that essentially a module is subject to the same forces of change. Right? We say if you have high cohesion, we're all changing for the same reason. Now imagine that I was writing an insurance application. And in my module, I essentially allowed both the claims team and the underwriting team, depended on, for example, that module, and made changes in it. So the claims guys made changes to some of the code that dealt with policies because it helped them do claims. And the underwriting guys made changes to some stuff around policies that helped them do change. I've now got a lot of reasons to change. We may find that the claims team and the policy team are fighting each other over this particular piece of software and saying, well, I want to change this, I want to change that. We may find they have really quite different requirements. The claims team are writing a whole lot of code that the underwriting team never touch. And our problem is we're getting a lot of churn and change in this one module. And we also may find that we get it's completely unrelated concerns creeping into that module. And the kind of when we talk about a big ball of mud, one of the things we're talking about is that having low cohesion. Everything is kind of tangled together. There's no one place to go to. If I want to go and add, if I have a particular use case, for example, price this given policy for somebody, right? Then one problem can be is everything's in one module along with the stuff that's essentially doing my submission process. The other problem can be the opposite way around, which is actually I have to go and change it in 300 places. And so I've worked on systems like that, where essentially there used to be a recipe where effectively in order to change for a given use case around how we were pricing a portfolio, there was literally a document you downloaded which had the 14 places in various parts of the code base that you had to actually go and change stuff. So what we want is to keep things that change together, and keep things that don't change together apart. Right? And to do that, we need to look for the forces of change. This goes back as far as there's a famous paper by David Parnass called On the Criteria to be Used for the Decomposition of Software into Modules. And at the time, what people did was tend to basically build modules around the flow of the application. But Parnass's point was that's not a good idea. What you want to do is build it around basically change. Things that basically are unstable and at a low level need to be separated from things that are effectively high level and stable, right? So you need to keep things that change together. And so Martin's book has a lot of information basically on that. Okay. So layering is just one of the kind of strategies that people get into to manage this kind of process. Okay. Oops. So here's a typical layered structure. And at the top layer, we basically have the UI. In the middle layer, essentially, we have the domain model. In the bottom layer, we have infrastructure. Infrastructure people quite often think about as the database. Do stand up and down quickly at the back if you can't see, or download the slides. Infrastructure is quite often the database. It may also be a call to an external service. So, for example, if I need to look up postcodes, it may be I'm calling an external postcode provider or a payment system. So it isn't just a data layer at the bottom. And in the traditional model, basically, a call comes in, goes to my UI layer, and I tend to call and exercise some objects in the domain, or maybe I call directly down to the database and get some values out. Okay. One of the key ideas in layer, there are a few key ideas in layering. One key idea in layering is essentially that it's like a cake, a layer cake, and everything stands on top of each other. And so when we depend, I can only depend on things that basically are below me. So the UI can reach in and use code in the domain or the infrastructure. But the domain can't reach up and talk directly to UI widgets. You have to always basically depend downwards. This prevents what we call cyclic dependencies, where effectively I depend on you, you depend on me, and it's then very hard, almost impossible to build the software. Okay. The other thing that layers do essentially is they perform, if you like, some encapsulation. So we say, I'm going to collect together a whole lot of stuff that does a similar thing, right? So I collect all of the things that are part of my domain together. I collect all the parts of my infrastructure together, all my UI together. And that has some value because particularly if we put some kind of abstraction, which is usually called a facade, make a very coarse-grained API to this layer, I can do two things. One is I can hide the implementation details from other layers. So in order to use this infrastructure layer, I quite often don't have to know about the details of how I talk to the infrastructure. I may have a data access object or a repository defined, and I use that instead. I don't know anything about the interior details. The other thing that lets me do is change stuff. So swap one implementation of a layer for another. Now people always say, oh, no one ever swaps a database. I mean, I've worked a lot of places. I've swapped databases in most of them. But I've also more commonly changed the technology that I'm using to do data access. So Ada.NET to Dapper to Hibernate, they quite often shift around, right? And if you have a layer, you can make that change invisible to essentially the layer above the domain. Otherwise, you have to go into your domain and start changing that as well. But the other thing you can do is substitute fakes or mocks at this level, right? So I can use an in-memory database when I'm effectively working before I get an actual real database. And finally, one of the things that a lot of agile developers talk about is deferring decisions. Quite often when I'm working early, what I'm really trying to do is explore my key part, which is the domain model. I may not need to make a decision at that point exactly how I persist things. The technology may not be needed to be decided. I could actually defer that decision until I know more about the qualities of persistence that I need. I may not yet have decided at the top layer whether I'm going to expose everything by REST, by GraphQL, or whatever flavor of the week it is that it's with this week. But it may not matter to me too much because early on I may want to drive the actual model. And I can test at different layers quite easily. So I can test at this layer, for example, because I can substitute or mock out other layers. So overall, layering is a useful strategy for organizing our code. So just a quick summary, we can reason about layers. So that's one of the other things we didn't talk too much about. So I can make from one layer, I can make some reasoning about the layer below behavior without having to understand its details. Implementations, defer decisions about layer implementations. You can minimize dependencies between layers. So if you have a facade, you can essentially reduce the surface area of a given layer to a small API that hides the implementation details. And that can be useful for testing as well, right? I only test the facade, not the implementation details, so I can change the implementation details without having to basically change my tests. My tests just show me that that new implementation is correct. And that can be very useful for things like data access. Sometimes what we do is we divide this domain layer into two parts, service and entity. By the way, layering essentially, these are conventional layers, but you can have as many layers as you want. It's the active layer that's important. If you look at, say, for example, for DDD book, one of the things Evans talks about is having quite a significant number of layers within your domain. So you can have multiple layers in the domain. This is just conventional. But in terms of our argument today, service and entity is quite a common distinction, right? And what we're really doing is we're distinguishing between two types of business logic in our application. Domain logic, and domain logic essentially the best way to think of that is it's relating to the critical things that the business needs to actually do. It's rules that effectively you are encoding into an application. So it's my rating engine for your insurance policy that figures out the fact that you smoke and you're overweight is a problem and we're going to charge you more money, or the fact that essentially you have points on your license means we're going to charge you more for the insurance of your car. Apparently being a journalist in the UK makes you a very high insurance risk for cars. I have no idea why. An application logic, which is often related to the workflow. So we're saying, actually, there are a number of steps in this process, and I want to effectively separate those out as the application logic, the flow of a particular business transaction that operates on a number of individual entities. And remember, that's quite an important distinction we'll come back to in a little bit. So this service layer represents application logic and usually coordination and control. It's basically, quite often what happens is we create this thing called basically a service layer. And the service layer essentially says, okay, I'm going to provide you a facade, and you can just call me from your UI layer, and each one of those things in that service represents a flow of some particular business transaction. So quite commonly, we actually also use that as a transactional boundary. Here is a transaction running basically within the system. A business transaction would also maybe a database transaction that says, here's an operation that I want to complete, and it has certain properties that you can reason about. And we may also do things like security, right? You have access to this particular part of our API at the service layer because you are authorized to run this particular operation. And there are some variations about how we implement this. So this idea called the domain facade. The domain facade says the service layer is just a thin layer over my domain model, which consists of objects that hold all the behavior. So in this model, we say, hey, our domain model should have objects that represent things in the field we're reasoning about, a policy object, a claim object, a rating object for insurance, for example, or in our case, how do I work things like a document version, ideas that are concepts in your domain, all the behavior should live there. And all that your facade does essentially says it's a very thin layer that essentially says, well, I know in order to perform this particular operation, this entity has the understanding of how to do that, and I will simply delegate control to that particular entity to do it. And this gives you a very thin facade that doesn't really have any kind of business logic in it whatsoever. So it's just a boundary, it's a layer boundary that essentially passes operations down to the domain. The other approach is called an operation script. And in the operation script we say, actually, I think only some of that logic lives within individual objects that form part of my domain model. But the workflow and overall application logic should be surfaced up into the service layer itself, which should have responsibility for running that particular logic. And so what tends to happen is we have a kind of script which says do this, do that, if this, do this, that do this, if that, do that. And they kind of can be thought about as orchestrating the individual domain objects. So in this kind of model, you effectively get an idea that basically you have each one of these services. Quite often we get implementations where you get a class, it's static, you can't create instances of it, it has methods on it, and those static methods on it, and those methods essentially are the ones that then create the relevant objects that are actually needed and pass through the workflow. I'm sure some of you have seen .NET system design like that. It was very popular 5-10 years ago. Okay. ports and adapters. So ports and adapters are a layered architectural style. It's sometimes referred to as the hexagonal architecture, and that reference comes down to basically the shape of the diagram, which we'll see in a second, used to produce it. Now the key thing to understand is that we have three layers in the ports and adapters architecture. We have what's the confusingly called application layer, and that's essentially where our policies and business rules go. So in other words, our kind of domain model lives there, right? And use of application, unfortunately, has confused a lot of people because people confuse that term application with the overall running system, and as a result, people get confused about what ports and adapters are. But application, when Coburn uses it, means essentially that domain model in the center of your system. Then there are adapters. And adapters are essentially how we get input into the system and how we get output from the system. So an adapter, what we call a primary adapter, or one that a primary actor, so basically that's someone using the system or another system calling he uses, could be something like effectively an HTTP API for a system calling you. For example, it could be something like rich UI and web forms, and it could be a command line interface. It can also be tests. And that's essentially a way of saying, I want to drive the interaction of your system. Okay. And there's a secondary adapter, which goes to a secondary actor, which is basically for outgoing stuff. So that's basically, I'm calling your database to persist data. I'm calling a message queue to raise basically an event on your messaging infrastructure. I'm calling SMTP to send an email as a result of your interaction. Okay. And between the application and the adapters is a layer we call the ports. And the ports you can think of essentially as a service layer. They are where effectively they form effectively a facade over the application that the adapter calls. And again, you can implement them in either basically an operation script way or effectively a domain script way, where effectively you either say all the behavior lives in my entities or some of my behavior lives basically in my port. So this is what a hexagonal architecture looks like. So this outer ring is basically my adapters. Let's stand over here so you can see. And you can see I've got a number of adapters here. So user side, I've got HTTP and GUI. Over here, database, I've got database adapter. And over here, I've got some different types of adapters for notifications, like MQP, SMTP, WebSockets. In the center, these little circles represent effectively my entities in the system. Right? This is where my code lives that basically is doing some work. And in here, this line, if you like, with the names, user side notifications, and database, is the port, that layer. And the idea is essentially, the reason it uses port is this concept basically of a application exposing ports to on the operating system, so you can call it. The idea is that the application layer here he talks about is exposing ports so it can be called, and effectively these adapters call it, right? And one of the ideas is that effectively I can have different types of adapter calling my same port. Right, so that's the adapter, that's the application, and that's the port. Now we'll show you another diagram of this in a second, but just a reference on this screen, the important thing to understand about the way this architecture works is that all dependencies are inwards. So adapters depend on ports, which depend on the application. So that's essentially a model. Is it easier if I stand this side? I think more of you can see, probably. So this is a layer diagram for hexagonal architecture. As you can see, essentially, the adapter layer represents the equivalent of our old infrastructure and UI model up there, right? So in our previous layer diagram, infrastructure UI, they're combined in this model. They are both the adapter layer and the outer ring. At the bottom layer, I've got my application layer where my policies and rules exist, and in the middle layer, effectively, I have my port layer. This is really equivalent to my domain's service layer, and this is really equivalent to my entity layer. And notice, essentially, I depend all the way in. So one of the questions that comes up is, well, if I've got something in the port layer, and let's say, for example, it's my secondary port, and it's talking to my secondary adapter, I want it to, which basically talks to database, right? There's a problem here, isn't there? Because my port can't depend on my adapter. My adapter can depend on my port, but not the other way around. So how does that work? How do I essentially say, well, I want to call some database code that lives there? And the answer, effectively, is you define an interface at the layer of your port, iRepository. pick a name. And then you say, okay, in the adapter layer, because I can depend on this interface, I will implement a concrete repository, nhibernate repository, EF core repository, whatever I want to call it, but probably usually a repository by name, like user repository. Okay. And then at runtime, what I need to do is inject a concrete representation of that particular type into the system. So that effectively that's where dependency injection comes from. This notion that I declare a dependency on a iUser repository, and at runtime something what we call the composition root, in other words when you come into the application, says in order to build this application I need to effectively inject a concrete representation into that particular piece of code so that effectively it will run. And this is what IOC containers were built for. They have been much abused and badly used over the years, but IOC containers and dependency injection were built to basically allow you to continue to layer in one direction, but have this code effectively be implemented in a different layer. Does that make sense? That's if you ever wonder what DI is about, that's what DI is about. Okay. On domains, let's talk a little bit. I'm going to stand over here for a little bit because I think it's... okay. So this is Ivor Jacobson's book. Anyone read it? Apart from me? A couple of people. Wow, yay! So it's mainly famous for use cases. This is what a use case looks like. So the idea essentially is I have some kind of actors, and effectively they are... it's a map of basically the behaviors that we want to model in or not model in our system. So here essentially is a use case model around effectively ordering some food. And you can see there are given interactions that we may or may not want to basically represent in our system by code. Okay. I'm not teaching you use cases, so just get an idea. You need to get the idea of it. So one of the things that Jacobson came up with is this idea called boundary controller entity. And boundary controller entity was a way of modeling use cases if you had them. So a boundary object, this is the UML notation for a boundary object. This stuff has its own UML notations. Okay, so this is a boundary object, and the boundary object is anything that interfaces with the actors of the system. Actors in the use case word being something external. So basically a user wanting to type something in via a user interface. A database where you're persisting data to. Another system that you're talking to look up information or exchange it, right? We can see a pattern here, surely. Okay, so a boundary object basically effectively is that. And here you can see a diagram effectively of a recycling machine where effectively you've got a customer panel or a receipt printer. They are all boundary objects in the system. Okay. So an entity object in this model is something that has state and the operations that essentially depend upon that state. So the way we can slice up our domain a little bit is we can say, okay, here is something like address, right? And here are all the operations that depend upon address. And that's one way of figuring out what lives in an entity and what lives in a controller or interactor. Okay. And a controller sits between a boundary and an entity. Boundaries are not allowed to talk directly to entities. And the controller says, I will mediate the conversation between these two. Now, a use case is a description of the way the system is used. It specifies the input to be provided by the user, the output to be returned by the user, and the processing steps that are involved. It's effectively the workflow. And some controllers or interactors essentially are where you implement a use case. And quite often you are advised to name that controller after that use case. So you say, this is my rate policy use case. So it's the entry point where you can track that use case. And this has a significant advantage. It means when I want to go and look at the code of my system and understand how we do rating of a policy, where is the code behind this thing that we do, I simply go and look for the use case describing rating a policy, which is a controller in the system. And effectively I can find the code, and the code will drive certain entities which will effectively have the state and the behavior that depends upon that state inside them. So it provides the application logic. So, for example, it will load entities from the database, for example, and persist them at the end, raise events, etc. It'll do some of that work, but it'll also do things like say, oh, well, I'm going to decide whether you're a gold customer, I need to take this particular route, etc. Okay. So the use case lives in the controller or interactor. So we end up with a model that looks a bit like this. There's the actor on the outside, the individual, and essentially he's talking via a boundary, UI for example, or an API, and he's then talking to some control objects which effectively then orchestrate the behavior of the entity objects. So you can see that these structures again related. Right here is our adapter port and application, and we can see that our boundary is really Coburn's adapter. And our port is really Jakobson's controller. And our application layer for Coburn is where our entities live. And Coburn's quite explicit. He says that a port is the use case boundary. Right? Use cases become problematic when they're only technology concerned. So what we do is we say effectively, I want to take my use cases out of where technology lives. And by that really he means the code behind for your Razor page or your web forms page, even worse. The event handlers on your GUI, right? Take the code out of there, because in order to test that, for example, I now have to write a test which spins up that particular piece of infrastructure. Now my tests are dependent on the infrastructure. All those people that write their tests and they spin up their MVC controller, one of the problems is if I wanted to change from an MVC controller to something else, my tests have got a dependency on the controller. That's no good to me. I want to depend on the use case. That's what I want to drive the tests of. And so that's that controller layer for boundaries, controllers, and entities. That port layer for hexagonal architectures is where we actually write our test. Don't get confused, by the way, between MVC style controller and boundaries, controllers, and entities style controller, which is also a port. Some people use the phrase boundaries, interactors, and entities to try and make sure that you don't get this confused about which controller it is. The controller is a stereotype. In other words, it's a type of thing with a certain behavior. It's not a specific MVC controller. So here, looking at our hexagonal architecture again, you can see we've got boundary objects, entity objects, and control objects. Right. So tests focus on the behavior at the use case boundary. So here, basically, we're saying we're unit testing at the port. It's the use case boundary. That's where we write our tests. Don't write them against the entities. It's too granular. Don't write them against the adapters. You now have test that depend on technology concerns. Write your tests against the port. I do a much bigger talk called TDD Where Did It All Go Wrong, where we talk about this issue. So if you're interested in diving in depth to that particular question, that talk will talk about it for you. You can find that online. We don't tend to test the adapters. We have some integration tests to test a hookup of a particular port. But you can then also use some system tests at the outside to effectively make sure everything works together, right? So really your emphasis is pretty much on doing most things by unit testing at the port boundary with a few tests around the outside to give you confidence. Okay. The use case controller. Let's go over to this side and stare at you all closely. Okay. So this is essentially, by the way, vertical slice architecture. So this is, boundary control and entity is vertical slice as well, really. Okay. So the use case controller pattern was created in 2001, or catalogued to be a better way of saying it. They didn't create it. They essentially catalogued that this pattern existed and people were using it. Baguier, Souza, and Pinto. And what their question is how do you design systems that basically have use cases? And they wanted to preserve the idea of the use case. They wanted to be able to trace back behaviors to a given use case and make it callable from UI and open to extension. That's a point here which is a bit different from everybody else. They're saying they want to be open to extension. What they mean by that is effectively I want to be able to compose things. So if I've got one use case, what I'd like to actually be able to do is have, say, a macro use case call that other one. So sometimes I'm basically doing a bulk operation. Okay. Here's a typical use case for an order processing system. And that's typically what you used to end up back in the day. I'm not asking you to understand that diagram, by the way, called basically a activity diagram. We don't need to worry about what these are too much. But this behavior here, this flow, is essentially what we mean when we talk about basically application logic. That flow of actually going through and saying, okay, effectively, do we have more of this to do? What information do we need? That kind of thing, etc. What are the states we move through basically in this item? Okay. So that looks a bit like that. That's a classic use case realization. You can see there's a place order. We've got an interface where the user types in their order. Manager's a really bad word. I don't ever use that. But here's the place order use case, and it involves the order and product entities. Over here, we're updating accounts as well. So we have an account manager use case basically, and an account entity. And the idea is place order is going to basically have some kind of interaction with the update account use case. So it needs to call it or work with it in some way. And so in this kind of model, now they made a bit of a mistake, which was essentially to use view and model to try and make it sympathetic to the idea of MVC. Forget that, it's a bad idea. But the model there is essentially your entity, and your view there is essentially your boundary object, because the view is how I talk to the outside world, and the model is my entities. But the use case controller, as you can see, essentially talks about an idea of starting and finishing. It's a flow. It's moving through various states. And this idea over here, extensions and inclusions, they're pretty much the same thing. They're effectively plugging in other effectively use cases. Extensions just have kind of some precondition in them. Okay, the details are not necessarily important. We're just trying to show you that this is a kind of old idea that can be synthesized. Okay, and the model is identify use cases. For each use case, you can create a use case controller, and then create the entity and boundary classes you need to implement. So you can drive TDD against the use case controller, and then basically provide the implementation data as you go along. And then you create extension hooks for related use cases. One of the things they're talking about is saying, really what you want to do is package your use cases in a separate layer. So one of the things that, I'd push back about is people saying they were doing vertical slice architecture, we're not doing layers. They are doing layers. There are layers throughout the idea of vertical slice. Okay. And it gives localization of business rules and policies, and easier replacement of universal system concepts. We talked about this before. Effectively, we've got all the rules and policies basically localized, but we can easily replace some of the things like the boundaries, user interfaces, etc. I can swap one user interface for another. I could build a REST API over what was once just basically a web API. Okay. And flexible configuration using plugin or extension model, etc. Okay. One interesting thing to note is that they say one way you can implement this is using the command or command processor pattern. So this idea of saying I take a command and I basically fire that off to some kind of handler, and along the way I may complete a number of orthogonal steps in some kind of chain of responsibility. Okay. Anyone who went to Jimmy's talk yesterday would have seen him doing that in vertical slice, and that's basically in this idea of use case controller. Okay, clean architecture. This is what the clean architecture looks like, which essentially is a synthesis of all these ideas. So in the center, we have our entities, a la Jakobsen we're talking about earlier. Surrounding it is effectively our use case layer, essentially, which is where our controllers are living, essentially where our ports. Here, when we talk about controllers and gateways and presenters, we're talking about how we work with a given framework, right? So this is where effectively we implement our ASP.NET MVC controller to plug into the outer layer. The outer layer essentially is everything beyond us: databases, frameworks, external interfaces. So what Martin's done effectively is just make these layers, name them a bit differently, but make them clearer about what the combination of these events all is. Okay. So sorry, that slide is a little bit hard to read, isn't it? Let me see what happens if I change the theme. Whoops. Let me try again. Slideshow. Better-ish, isn't it? Okay. Right. So, what happens is, by some mechanism, stuff comes into our application. We have basically a boundary object, which is essentially how we relate to whatever framework or mechanism is delivering inputs into us. We construct basically a request model from that input. We call an interactor, some kind of layer that deals with the use case, right? And that basically orchestrates an operation on a number of entities. This is entity gateway, so you might have to talk basically potentially to something to load those entities up. Okay. So typically, for us, what you might see over this end is they've got some kind of API framework, like ASP.NET MVC or Web API, and effectively I'm writing my controller, and essentially what I get into the controller is it takes the post variables and turns them into a request model. I pass that down to my interactor, and then I get back a response model. Now, where I have MVC inside something like ASP.NET MVC, it's really all at this layer, right? So my web controller effectively is dealing with that down here. So don't make the mistake of believing that's that other layer. And then essentially, If I had basically a database down here, that's potentially where I get my entities from by Entity Framework Core or the like. Okay. Wow, that was an interesting change of style, wasn't it? Okay. I wasn't expecting that. Right, let's show you some code, and then we'll come back and hope that we can get that design transition to something that will not kill the rest of my slides. Okay. Right, can we switch over to... I switched screen, and I'm not appearing on here. No? So I've just switched off the PowerPoint presentation. I can mirror screens. Want me to mirror screens? Okay. Just mirror the screens, guys, and then you'll be able to see what I can see. Show mirroring in the mobile. That's right. I love the way it goes black. Okay. Alright, let's show you this. Okay. I'm going to increase the size a bit. Can we read that at the back-ish? A bit bigger? Good? A little bit bigger? Okay. So here's it's my user demo application. I'm just going to run through what the API does for a second for you. So I built this fantastically complicated demo application that essentially says you can post to me some greetings and then you can ask to get them back. Right? And the reason it's very simple is because that means we're not worried about what the domain actually is in the context of this operation. So here I'm going to basically say I'm going to go away and get... Why is that not showing me my plugin? Hello? What's gone wrong with you? Okay. So this is using a plugin called Dynamic REST. So I've made a call to the web server, and the web server said effectively I haven't got anything at the time being. And then I can post in a greeting request. I get a response back that tells me essentially, here's the ID of what you just gave me. I can post in another one, right? And I can think I've got a third one down here. And then when I go back and get them all, I get the whole list, right? And I can ask for an individual one by ID, but I'm not going to show you that. It's not relevant to the conversation. Okay. Now, this is typically how a lot of people might naively have created their initial controller. I'm doing everything essentially in the controller. There's no layering at all whatsoever basically available to you here. So you can see here in the get, I'm just saying, okay, well, create my entity framework context and go away and run basically a query, putting it into an array and iterate through the results and display that out effectively on a result. So I've got some MVC logic going on, but I've got no real layering. You can see here, for example, in a post, ignore the loads of console stuff, we'll explain that later, but you can see here essentially I am creating a context, I'm adding something. I do have a repository just to hide away some of the entity framework core cruft, but yeah, essentially just adding something to the repo. Okay, and probably many of you have seen applications that look a lot like that, where everything is just straight in the controller. And the problem now is that I can't get at that code to test it independent of the controller, or to change it, or to use it from somewhere else. If effectively that if some of that logic was usable somewhere else, that'd be useful. And you can see here I'm repeating similar logic. You'll see that effectively in a lot of places I pull back this result object, right? Or I pull back a result object. It's doing exactly the same thing. It's a repeated code. So what I might decide to do is say, well, I went to that talk and Ian talked about layers. So the first thing I'm going to do is I'm going to pull in... Oh, why did you do that? You never do that normally. Okay. Right. Okay. I'm going to basically create my layer. And what I'm going to do is say, here is my layer called greeting facade. And I'm going to move stuff down there. So now I've got a layer. And now what I could be able to do is, for example, I've got facade get async, and I've got facade basically greet. Well, it's cleaner. Look, I've got all these places where I'm doing get async, and it's all using the same code. So I've removed some duplication. Also, where I've got had that horrible piece of console stuff, I've now got a thing called regreet. That's fine. It's taken out. It's much cleaner and easier to read. And I've got a nice thing for add. Okay, and I can go and navigate over to where that's done. And you will find essentially I've just moved all the code down here. Now the thing is, this is much more testable, right? I can now write my tests against this facade layer, and I've removed the dependency I have on the MVC framework. So if I decide to change frameworks, I know that sounds crazy, but once upon a time people believed that web forms was going to be here forever. Right? Imagine that I still deal with code written in web forms because the people that wrote it believed it would be here forever. And I can now test this layer quite independently. Now I may decide I'm going to go a step further. I may decide that essentially I've got a lot of stuff in that one facade. And maybe, even though in my case I'm just doing simple CRUD, if my add operation and my delete operation had a lot of additional business logic around what it was actually doing, there'd be a lot of complexity in one single class. And really, add and delete are quite separate use cases because, in a genuine application, they might have a lot of additional flow in them. So what I might do is decide to basically take hold of the single responsibility principle and break all of this up if I can. Yep, so let's get rid of that. Okay, so now what you should see is that effectively in my greetings controller, I have an add greeting service and a regreet service and a greetings by ID service. And all they've done is I've taken the individual items there and said, okay, I'm going to split that up and make it its own individual class. So now effectively I've got something that looks like it's handling individual use cases. Okay? Now, I could look at that and say, you know what? That's really surely just the command model. Okay? The reason it has to be from disk is because I'm shifting between repos. And OmniSharp needs to get a, OmniSharp restart. Where did you just go? I just told you to do that. Because I need to reinitialize basically its IntelliSense. Okay, so I actually can turn this into commands and queries. So I've got an add greeting command here, for example, right, which you execute async. So the add greeting command is very similar to that service, but I'm now explicitly calling it a command. It's something I want to do, and we mentioned before, effectively under use case controller, the authors were saying commands and command processors are a good way to implement this. Okay, and commands are natural transactional boundaries. So my use case is now a command that I'm operating on the system. And I can also encapsulate up because I may feel CQRS-y. I can essentially say, hey, look, my query is also something I can encapsulate at this level. Okay, that's just doing the same thing. And now I may say, well, hang on a minute. Now I'm talking directly to concrete commands, but wouldn't it be nice to have some kind of model where effectively between me and the final execution I can insert a whole lot of orthogonal concerns like logging in a command processor model. Okay, so essentially that's where we then move over to this. Okay, where let me just get this right. I'm going to say, okay, I'm going to bring in basically Brighter and Darker, which are the libraries, open source libraries I work on, but other libraries are available. Mediator does a lot of this for you as well, for example. And I'm going to say, okay, right. So this command processor and query processor here are just essentially command processor is Brighter and query processor is Darker. And what I say here is I'm going to basically separate the parameters from the execution. So the greetings, so for example, the add greeting request command now doesn't have a body. It just says, essentially, instead, here effectively is my parameters. And what happens at runtime is that we navigate to an actual handler. So the handler lives in here. You can see we basically call it the ports directory. So we're basically trying to be explicit about our architecture and surface that idea up. And there effectively is my add greeting command. And you can see on the add greeting command, as well as essentially doing the actual work we've been doing all along of adding something to the repository, we have these attributes. And that's what we use in Brighter to indicate an orthogonal operation. So it's a Radisson Blu model. We just insert more handlers into the chain. What we're saying here is you want to use some policies from Poly to control our retry or circuit breaker approach. We want to do some logging. So use policy comes out of the box. So this thing, for example, we're saying, I try and talk to the database and add your command. Oh, and by the way, if you fail to talk to the database for some reason, maybe there's a deadlock, maybe there's a temporary partition on the network, we'll retry the operation for you according to the policy. If the operation fails a lot, then we'll break the circuit for you so that you don't keep polluting essentially the logs with basically failed operations. And we'll log everything for you. We'll show you essentially entry and exit basically from that particular method. So by moving into that long chain, we've essentially made it possible for ourselves to put those orthogonal concerns into the chain before we reach our target handler. And our tests, I don't think I've got any tests in here. I don't think I've got any tests. But our tests, if we were going to write them, this is what we'd actually target, right? We would target this handler. We would say, I want to test this handler does what it's supposed to. And that means I can vary my implementation details a lot, and I don't have to rewrite my tests. This is really, over time, we've come to believe the optimal place to actually do our testing is at this use case boundary, which is basically our handler. So think of your handler as a use case boundary. Okay. Let's take off mirroring. Go back to some slides. I keep changing the color of my slides, so I have no idea what will happen now in terms of the format, but we'll work with it. Okay. So, ooh, that's created interesting lines across my screen, isn't it? Never mind, let's just live with it, the fact that it's changed stuff for us. So this is the service facade. And essentially what we're saying is this is kind of the very simplest level where effectively we have some kind of class and it has methods on it which represent the individual use cases that we're talking about. Okay. I'm too far away to change the page. Oops, something's crashed horribly. Kindle quit unexpectedly. You don't really care about that, do you? Okay. So the interface segregation principle is a first step. We didn't really show that, but essentially I might say that, well, effectively what I want to do is break up my, that's gone hideously wrong in that format. Let me just change, if I can change back to the original design, and then we may find that our lives are a little bit less painful. Let's hope both readability and layout. Okay. So essentially we've got this idea of saying, well, I could effectively decide that my service consists of a range of interfaces. So I could say, actually it consists of a update my thing, this, update my thing, that, where each one of those is an individual use case, right? And again, it relates to a single responsibility. So we're creating cohesion by saying each use case, not all the use cases in one class. One of the other things you're concerned about is if you have one big fat class that essentially implements all of your use cases, your problem is it has a lot of dependencies. And so things that you don't depend on in your use case, if they change, you effectively have to retest your whole class because something else changed not related to you. So for better cohesion, you want to break up into individual use cases. Then we get to the model we were talking about saying, okay, single responsibility principle, so effectively I'm going to just implement each one of those interfaces as its own class. So effectively a use case is now an individual class, not basically a service facade class. Right? And then we get basically into the command pattern. So this is the command pattern for those who've never seen it. Essentially what we have is this abstract notion of a command that you can execute, and the execution on the command is what exercises your entities in your domain model. At the client level, you essentially say, well, right, I'm effectively going to implement, deal with a concrete instance of that. Okay. And so what happens is the client calls the command and says create a new one, and then effectively it says, quite often it's the whole bit about storing the invoker, we'll just skip for a second because it's not relevant. Then you effectively want to execute effectively that command, right? So the command's very simple. I've got an execute method on it, and effectively what I say is do my stuff. The parameters go in as in the constructor, and the execution is there. And your command is effectively where you create a use case. Right. I don't know why I ended up with this projector model, but let's try flipping. Can you see that better? We'll just do that, maybe. Hang on. There we go. Right. So this model effectively is showing you the earlier diagram basically with commands. So where we had interactive before, we're saying basically just use a command. Okay. And effectively you can see our delivery mechanism, which effectively is our MVC, as for MVC, our boundary are effectively our MVC controller, where we create a request model, which essentially is the form post variables that are basically coming as a parameter to our web controller. We then turn them essentially into properties on our command, which we then effectively execute to basically bring out our entities from the database via Entity Framework Core, and then deal with them. Then we get a response back. Okay. Assemblers. So this is effectively You may have to deal with data transfer objects between layers, and an assembler is a way of doing that. Automapper is an example, essentially, of an assembler, which is a way of effectively creating data transfer objects from domain objects. Don't write the code by hand, right? Okay. This can lead you towards command query separation, which is not the purpose of this talk, but you can begin to understand how you're building up a command model and a query model, which basically from your UI. So you have some kind of task-based interface, which is creating commands, which is changing the state, and a query model, which is then interpreting that state. And that command query separation is a fairly easy step once you begin to work in this way. Okay. So one of your commands is essentially a use case and a use case controller pattern, a vertical slice, moving through those layers. Okay. And we also talked about command dispatcher. So command dispatcher effectively was this idea essentially that we said, well, what I want to do is separate the execution of the command from its parameters. So essentially what I will say is essentially I'll take a whole load of commands and I'll register them. And I'll register effectively when I basically pass a command, it will go away and look up the relevant handler and call its execute method. Okay, so here you basically get a sequence diagram showing you essentially I register the handler with dispatcher, and when effectively I actually want to invoke a command, what I do is go away and look up the actual handler, and then effectively invoke the handler, passing it the parameters. All right, seeing all that. Okay, I think that's towards the end. How are we doing? We've got about 4 or 5 minutes left. Okay, I will just quickly show you that bit of code again, just to final state, and then we can ponder, and if you have a question, let's do that. Let's mirror the slides. System preferences. Oh, you can see that. Okay. Okay, you can see my code. Right. So, just to kind of look at that final state of the object again. You can kind of see you've got a controller. The controller is creating a command. It's basically using a dispatcher to send that command basically effectively to a handler. And orthogonally, we're basically running a number of steps to basically handle orthogonal concerns. For example, in our case, retry logic, circuit breakers, and logging. By the way, don't do transactions in your orthogonal steps. It's painful. We tried that. And what happens is essentially your transaction boundary, 1, it may span other orthogonal steps, so it's held open for a long period of time. And 2, when you're actually inside your handler, really you want to narrow the transaction to be as short a window as possible. If it turns out some junior programmer comes along and makes a call to an external service, your transaction is now spanning that external service call at the same time, or even more commonly writing to and from disk. So avoid using basically putting transactions into those orthogonal steps. It hurts in the end. Okay, so this is basically post, and you can see we're similarly using a query for get ID, and you can see then over there, just to remind you, then what happens is you end up looking like this, a greeting command handler other, and that essentially is where you write your use case. Right? Think of this as your use case. Your command is your use case boundary, and you write it here. And in here, you can deal with entities. You can also actually, in this model, you can vary it. You can have what we call a transaction script. So you could just have no entities at all, literally just talk to the database if you wanted to. In some environments, that's actually just as appropriate, not to have, you have no real policies or rules, you're just doing CRUD. Then effectively, sometimes what you do is just put that CRUD straight in here into the handler, and you have no underlying entity layer. Okay. Any questions? None? I've stunned you all? Okay, so the question is, if I'm in my interface layer, how do I understand what's happened in my domain object? So the answer is events. Right, so what you have to do is raise events. What you don't do usually is raise the event directly from the domain object. What you actually do is query in the port layer, in this handler, you'd essentially query the domain object, ask if it has any events, and then you would essentially be able to publish them. And you publish them generally or quite often to an interface, or you can publish them to some other model. So we have here, I think in this one, let me do this one. With the workers. So this version, which I didn't show you for time, but I'll show you now. In this version, what we're going to do is say on the aggregating command handler, I'm going to post an event. I don't know if you can see that. Let me try scrolling the screen up a bit. I'm going to post effectively something out here. So I'm saying I'm going to raise an event in response to what happened internally here. Now, when we're using post in Bright, what we mean is we're going to put that over a message queue because we think something out of process is going to handle that. But we also have essentially publish, which does it in process. And you simply just grab another handler to pick that up. Effectively, if I want to go all the way to the UI, right, and not to another handler, then essentially what I'm really doing quite often is just querying the results basically through the UI layer separately. So I do a separate query that says what are the results of that operation once it's completed. We would tend to know when the operation is finished. Either you basically got an async publish or send, in which case effectively you just write on your completion essentially that effectively you want to go and then query the result for it, or we won't return or block until basically you process the actual information and then you have to go and query it. So what was the difference when we're publishing an event and posting the command? Yeah, yeah. Yeah, this one basically puts it out of process to a separate out of process worker. Just actually completely out of the application. So it's using an idea basically called task queues. So a task queue basically says I've got some work that I don't want to handle in process. I want to offload that to some other system to do. Say for example, if I was actually going to mail that to you effectively via SMTP, it's a long running operation, and what I do is raise it. So over here you'll find we've got a regreet command handler, which is handling that work. And you'll find down here, this is a separate basically application that's running that effectively creates what we call dispatcher that listens effectively message on a queue and then wait, and as it receives them, it will handle them. So this one is listening on this particular to this particular topic, notification, and RabbitMQ, and creates a particular queue for that. And essentially, when it receives those, it will effectively automatically send them to your handler for you. But you can play with the code. It's all on GitHub. I'm going to have a look at Bright Tweaks. We've got quite extensive documentation to explain how it all works. Anybody else? Any other questions? All right. Then I think we're done.